Excuse me for 1 second. Okay. Thank you. Today I just wanted to emphasize our responsibility when it comes to safety. And I know we already do that to some degree. Just wanted to share how we do that in the Austin District. Our goal is also, preserving pavements, but we also look at preserving property and life in a lot of cases. And so we had an overall goal in our district to really reduce our crash and fatality rates. We developed a risk assessment program to do that. We looked at some major areas that we could probably try to improve, which is narrow widening and our surface friction levels. And so I'll go into that. This is kind of a general schematic of what our 4-year / going into 10-year pavement management program looks like, and kind of a little schematic. And as you can see, today I'm going to be focusing on that first goal, but there's a number of attributes that really go into that. And so when you start trying to get your arms around all the data, it gets really hairy. And so we tried to come up with a approach that would help us, look at these goals overall. And so we came up with something called the Roadway Safety Performance Index. This was developed we developed a methodology to try to bring in all the data that we have that way would be performance-based. It would look at multiple attributes of a roadway. It would be more proactive and reliable. That way we could not only see retroactively where we're having safety issues, but hopefully start to predict to some degree, project where we can start focusing our funds to increase safety. And so we went through a big data integration process of integrating CRIS data, which is our crash database. We also looked at some of the traffic databases that offered, ADTs, geometrics, speeds and whatnot, and also our PMIS. And so once we integrated this data, we created an Oracle database that started looking at different types of regressions to look at crash prediction models. And I'll show you that in a little bit. So we used 2 main regressions to do this, and we used over 20 attributes, like I said, 20 geometrics, pavement condition, roadway, and traffic characteristics. The data you'll see is only Austin District data. Not to say this is all universal type text data, so you could do it with your own data. It does not consider factors to the operator's health, impairment, or the condition of the roadway. We really wanted to drill down to the possibility of the road being the issue. Those regressions came out with these nice smooth curves that aren't, if you saw the scatter behind it, there's some pretty good correlation, but there's a little scatter to it. But there's 2 different indexes that came out of that. And basically that's the individual risk in a certain segment of roadway and the cumulative risk for a certain segment or corridor. But the good thing is it kind of serves just like our condition scores for pavements, but this is kind of a condition score for safety. And so that kind of really helped us identify, no pun intended, see where our hot areas are, basically where you see the red in the map. It also helped our wet weather crash reduction program because it helped us not only be retroactive looking at our skid and our crash data merged together, but also to calibrate it to see how predictive it really is. When you look at the top 10 most statistically significant variables that were in this regression, there's a lot of things in there, but there's only about 3 things in there that could be addressed easily and quickly. One of those things is lane width and shoulder width. Our narrow widening program could really help in this regard. And then skid number, which, our resurfacing program with high friction surfaces would help that also. So those are the 2 things I'm going to talk about today. So we're looking at assessing how our narrow widening performance is done in the past. Back in the day when Carlos Lopez was our DE, he was really interested to see whether we're getting the bang for the buck out of our narrow widening program and really seeing that we're getting reductions in run off the road or head-on crashes. Here's some general statistics on our Texas FM roads. So the objective of this was basically to look at the performance of these and how much they reduce not only the levels, but the types and severities of these type of crashes, and identify certain lane configurations and widths that actually optimize these reductions the most. And so we did a bunch of before and after studies of about 22 narrow widening projects in the Austin district. Here's some statistics of those. So crash data was analyzed over 2003 to 2012. There was a minimum of 12 months data. And so we had about 500, a little over 1,500 road segments that were characterized. We use this FHWA safety assessment to see the improvement before and after an observed number. And when you look at it, you know, it's definitely worth the while to do this kind of work. As you can see, there are significant reductions in all types, but also these two run off the road head-on were significantly reduced by our widening program. So when we go into severity, these are, you know, injury and fatalities and property. So you can see there still is quite a bit reduction in there. So the next step that we're taking now is not only just to see whether they're being reduced, but what configurations and widths and stripe widths perform the best in this regard. That way we can develop actually district standards to help reduce those crashes. The next thing is skid. We really looked at, you know, our network back in 2008 with our dense graded mixes when we weren't getting the skid life that we really wanted out of it. And so in 2008, we started with a high friction surface course policy. As you can tell in 2008, you can tell when we did that, these are basically Austin District overall average for skid numbers for our network. And so in 2008, when we started implementing high friction surface courses, which is defined as seal coats, thin overlays, PSCs, SMAs, or a concrete surface, you can see a significant increase in those skid numbers. So did that translate into reductions in crash rates? Well, based on this slide, it did. And so what you can see here are both the wet weather crash rate and then fatality crash rate in wet weather crashes. And you can see a fairly significant reduction from previous years. These numbers were normalized for weather because, as you know, in Central Texas, it's either flooding or drought. And so these numbers are normalized for that statistically. And so in Austin District, as you know, as a metro district, we've been growing, if you believe the daily vehicle miles, by a little over 2%, but in most areas, about 8%. So your probability for a crash should increase, but our data shows that we have the reverse trend for our wet weather fatality counts. This is kind of an overall view of what those reductions look like. So in conclusion, we use our safety index in tandem with our road assessment to really drill down exactly where we need to be putting our money and where our widening program needs to be and other safety treatments. We're reassessing our narrow widening practices, and our high friction surface course policy that we implemented in 2008 has currently been hardwired into our SOP, given the reduction in crashes and fatalities that we've seen over time. That's all I got. Any questions? Okay, thank you. Yes, sir.
Are you, for the high friction courses, are you doing that with RMCs, Cat 1 projects, and HSIP, or just one, or what?
Did everybody hear that? So the question was, are we doing the high friction courses in RMCs, Cat 1s, Cat 8?
And the
HHCs? All of the above.
All the above.
So basically, the pavement design SOP covers all resurfacing applications.